This is on section 3.3, the trig derivatives. Right, so 3.3, 1 to 27 odd, 31, 33, 39 to 45 odd. So let me show you those problems right away. Page 196, we have to go up to 45. So while I'm showing this to you, you see the sine, cosine, tangent, cotangent, secant, cosecant. They're there. We're going to get those derivatives. And just like the other derivatives, I will show you the derivation of them. I'm responsible for the derivation. You are not. And we have to go up to 45, so I think they are there. Okay. Let me just quickly give you the important formulas you need to put on your formula sheet and so on. Page 191, box 2, important limit. Limit as theta approaches 0 of sine theta over theta is equal to 1. Okay. You can make a table of values for that and get that. Another limit, page 192. Box 3, limit theta approaches 0, cosine theta minus 1 over theta is equal to 0. And then all the trig derivatives, bottom of 193, here they are. You can put these on your formula sheet. If we were meeting face-to-face, typically, I would make you guys memorize it. But there they are. I'll go over a derivation of them all. Okay. So here we go for the trig derivatives. So derivation time, some identities that you are aware of, sine squared x plus cosine squared x equals 1. Did you know that from trig? So that means sine squared x is equal to 1 minus cosine squared x. Likewise, cosine squared x is 1 minus sine squared x. Okay, limit as x approaches 0, sine x over x is equal to 1. You can make a table of values, 0.1, 0.01, 0.001. Okay, this happens to be an even function. So if you plug in negative 0.01, you get the same thing as positive 0.01. Sine being even, so sine of negative x over negative x is a negative of the sine of x over negative x, so you get the same thing back. Okay, so just for fun, let me show you sine of a very small number divided by the number itself in terms of a limit. Okay, so let me set that up for you, make sure that I'm in radian mode in my calculator. Okay, so my calculator is in radian mode, that blinking thing there. Okay, so sine x over x, so sine let's see, sine 0.0001 divided by 0.0001, just for example, 0.9999999, and now my screen is frozen. Hopefully you can still see that, but it's practically 1. Okay, so let me stop this share. Let's see if I can go back in. It's not letting me do it, so I will try it again. I don't feel like stopping the video, so sorry about this. Having technical difficulties, I guess. Let's see. See if I can get back in. Okay, I think we're back. So in any event, this limit is equal to 1. Okay, another limit, limit x approaches 0 of cosine x minus 1. Okay. If you factor out the negative 1, I have 1 minus cos x over x, multiplied by the conjugate 1 plus cos x over 1 plus cos x. It gives me negative limit x approaches 0, 1 minus cosine squared x over x times 1 plus cosine x. This is equal to sine squared x. Break it up into 2. Limit of a product is a product of limits. So negative limit x approaches 0, sine x over x, limit x approaches 0, sine x over 1 plus cosine x. We already know that this limit is 1. And if we plug in 0, that's 0 over 1 plus 1, which is 2. So negative 1 times 0 is 0. So therefore, the limit as x approaches 0 of cosine x minus 1 over x is equal to 0. Okay, we need that for some of the proofs. All right, derivative of sine x. By definition, limit h approaches 0, sine of x plus h minus sine of x all over h. Sine of a sum, sine x cosine h plus cosine x sine h minus sine x all over h. These two are combined and factor out the sine and take the limit of a sum being the sum of the limits. Limit h approaches 0, sine x cos h minus 1 over h. Then limit h approaches 0, cos x sine h over h. Okay, this is a constant as far as h is concerned, bring it out. This is a constant as far as h is concerned, bring it out. So I have sine x times limit h approaches 0, cos h minus 1 over h, plus cosine x limit h approaches 0, sine h over h. Okay, we found earlier that this limit was equal to 0. We just did that over here. And we saw that this limit was equal to 1. So I have sine x times 0 plus cosine x times 1, which is cosine x. Bottom line, derivative of the sine is the cosine. Now, how about the derivative of the cosine? Well, maybe it's the sine, but let's see. So by definition, derivative of cosine is limit h approaches 0, cosine x plus h minus cos x over h. Okay. And then there's a rule for the cosine of a sum, cosine x cos h plus minus sine x sine h minus cosine x over h. These two factor out the cosine x, limit h approaches 0, cosine x, cosine h minus 1 over h, and then minus limit h approaches 0, sine x times sine h over h. Bring the sine in front, bring the cosine in front, cos x, limit h approaches 0, cosine h minus 1 over h, minus sine x, limit h approaches 0, sine h over h. Okay, and once again, this limit we know is 1. We know this limit is 0. So it's 0 minus sine x or negative sine x. So a derivative of cosine is negative sine. The other 4 derivatives, we'll just use quotients of either sine or cosine that we already know. So derivative of tangent is derivative of sine over cosine. Use the quotient rule. Bottom times derivative of top minus the top times derivative of the bottom. So I have minus sine x times negative sine x. That's a double negative, so they become positive. Over cosine squared x. So I have cosine squared x plus sine squared x over cosine squared x. But that's 1 over cosine squared x secant squared. Bottom line, derivative of tangent is secant squared. Derivative of cotangent. Well, cotangent is cosine over sine. So bottom sine x times derivative of the top, negative sine x, minus the top cosine x times derivative of the bottom cosine x over sine squared x. This is negative sine squared x minus cosine squared x. That's negative 1 over sine squared x, negative cosecant squared x. Bottom line, derivative of cotangent is negative cosecant squared x. Secant is 1 over cosine. So derivative would be bottom cos x times derivative of the top, which is 0, minus the top 1 times derivative of the bottom, negative sine x, all over cosine squared x. So I double negative, I have sine x over cosine squared x, which is true, but normally you see it this way. I can break this up into 1 over cosine x times sine over cosine x. This is secant x tangent x. So derivative of secant x is secant x tangent x. And finally, derivative of the cosecant, treated as 1 over sine. So again, bottom times derivative of the top, 0, minus the top, 1, times derivative of the bottom, cosine x, all over sine squared x. So negative cosine x over sine squared x. Break this up into 1 over sine times cosine over sine. This is cosecant, this is cotangent. So derivative of cosecant x is negative cosecant x, cotangent x. I went through all this derivation quickly. You're not responsible for it. I'm responsible for it. Okay, but you are responsible for this table, bottom of 193. These 6 trig derivatives, put them on your formula sheet. Okay. And there we go. And there's one other thing that you want to know for this section. In problem 39, there's some problems involving limits of sine over x or something like that. Okay, if x approaches 0, so does kx. Okay, 5x approaches 0. Okay, so if I plug in 0.001, that's small. 5 times it is 0.005. It's still small. So if x approaches 0, so does 5x. Okay, so to do a problem like 39, limit x approaches 0 of sine 5x over 3x. What I'm trying to do is force this angle to match this angle. So how do I get this to be 5x? I can multiply top and bottom by 5/3. bring the 5/3 out in front. 3x times 5/3 is 5x. Okay, and now limit x approaches 0 sine 5x over 5x. You could pretend that says 5x. Okay, so that's a variation of this root. That angle has to match that angle, has to match that angle. Here it doesn't quite. You have 5x, and x, but as x approaches 0, so does 5x. So this limit is 1. So you have 5/3 times 1, which is 5/3. That's problem number 39. Okay. So in general, if theta approaches 0, k times theta also approaches 0 for any constant k. Okay. So that's going to be part of it. All right. So now for a bunch of problems in 3.3. Number 1, f of x is x squared sine x, product rule. So first times derivative of the second, derivative of sine x is cosine x, plus second function sine x times derivative of the first, derivative of x squared is 2x. So a little cleanup, x squared cos x plus 2x sine x. Number 5, find the derivative of secant theta, tangent theta. That's a product. So first function secant theta times derivative of the second, secant squared theta, plus the second, tangent theta, times derivative of the first, derivative of secant theta is secant theta, tangent theta. A little bit of touch up. Secant cubed theta plus secant theta, tangent squared theta. Number 9, y equals x over 2 minus tan x, quotient root. Bottom times derivative of the top, which is 1, minus the top x times derivative of the bottom, derivative of 2 is 0, derivative of negative tan x is negative secant squared x. And a little bit of touch up, that's a double negative. So I'm going to write 2 minus tan x plus x secant squared x all over 2 minus tan x squared. Okay, this one asks to derive the derivative of the cosecant. We already did that, so I showed you that already. So do that again. See, 3.3, number 7, y equals c cosine t plus t squared sine t. C is considered a constant. So the derivative of c cosine t is negative c sine t, plus the derivative of this is a product root. First function t squared times the derivative of second cosine t, plus second function sine of t times the derivative of first, which is 2t. And a little bit of touch up, negative c sine t plus t squared cosine t plus 2t sine of t. Okay, one of those limits, 43, again, the original was limit x approaches 0, sine of 3x over 5x cubed minus 4x. The trick is to divide top and bottom by 3x. Okay, and then the limit of a quotient is the quotient of the limits. Limit x approaches 0 of sine 3x over 3x. This is going to be 1. So that angle matches that angle. This one can still be x. If x approaches 0, so does 3x. So this is all going to be 1. And this is going to be very easy. So if I divide here, I get 5x cubed over 3x is 5/3 x squared minus 4/3. So that approaches 1, that approaches 0. So I have 1 over negative 4/3, which is negative 3/4. Okay. Going back to 3.229, as for the second derivative, it's quite clumsy. But bottom times the derivative of the top, 2x, minus the top times the derivative of the bottom, e to the x, all over 1 plus e to the x squared. Clean it up, 2x plus 2x e to the x minus x squared e to the x over 1 plus e to the x squared. Okay, it's a little bit easier if you factor out the e to the x. So 2x plus 2x minus x squared e to the x over 1 plus e to the x squared. So now for the second derivative, it's bottom times derivative of the top. So 1 plus e to the x squared times 2 plus 2x minus x squared e to the x plus e to the x times 2 minus 2x. So that was a product root right over there. Minus the top times the derivative of the bottom. So I copy the top, 2x plus 2x minus x squared e to the x. And the derivative of the bottom turns out to be 2 times 1 plus e to the x times e to the x. Okay, that involves something called the chain root, which doesn't apply actually until section 3.4, but I'm going to put that for now, and we'll come back to this when we get to section 4. Okay, and etc. I don't even feel like cleaning that up. You probably don't either, so I'll just stop right there. Okay, 3.323, find the equation of the tangent line at pi negative 1. So I find a derivative. Derivative of cosine is negative sine. Derivative of negative sine is negative cosine. Then they asked me to plug in pi. Negative sine pi minus cosine pi which is 0 minus a minus 1, 1. So point slope, y minus a minus 1 equals m times x minus pi, or y plus 1 equals x minus pi. Okay. All right. Let's see. So 3.3, number 41. Limit as t approaches 0 of tan 6t over sine 2t. So tangent 6t is sine 6t over cosine 6t sine of 2t. Now, the way it works is you want underneath here a 6t, you want underneath here a 2t. So I just do it. Okay, first I separate out limit t approaches 0 of 1 over cosine 6t, limit t approaches 0 sine of 6t, limit t approaches 0 sine of 2t. Now, this has to have a 6t, so I just put it. This has to have a 2t, so I just put it. And then I balance it. So I say this was 6t. So in order to make this 6t, I multiplied this by 3. So now I divide it top and bottom by 6t. This is really 1/3 here. So ultimately, I've divided by 1/3, which means I'll multiply by 3 in front. So this 3 is this division by 1/3 here. Okay, so divided by 1/3 is 3. Now I have limit t approaches 0 of 1 over cosine 6t, limit of t approaches 0 of sine 6t over 6t. I can sneak in a 6 here. Limit t approaches 0 sine 2t over 2t. I can sneak in a 2 here. And that's 1, that's 1, that's 1. So I have 3 times 1 over 1, which is 3. Okay. And then 45, limit as theta approaches 0, sine of theta over theta plus tan theta. Okay, I divide top and bottom by theta. So sine theta over theta. And this is theta plus sine theta over cosine theta. That's tan theta divided by theta. So that's going to be limit theta approaches 0 sine theta over theta. I know that's going to be 1. Over limit theta approaches 0 of theta divided by theta is 1. And then sine theta over cosine theta divided by theta, you're allowed to sneak the cosine theta down here. So limit theta approaches 0 sine theta over theta times limit theta approaches 0 of 1 over cosine theta. Okay, that's 1, that's 1, that's 1, that's 1, the wrong one. So 1 over 1 plus 1 times 1, 1 over 1 plus 1, or 1/2. Okay. All right, so that is section 3.3 on the trig derivatives.